Okay, so we're going to look at composite functions, their domain and range. Many questions, many problems that we will see in this video are a bit tricky, but we'll start with the simple ones first. So what's a composite function? A composite function is the one in which output of one function becomes the input of second function. So there's a convention to write it. I mean, if we just look at the definition, then we can say that composite function looks like this. And what's happening here is gx basically is the output of the function g, and that output has become the input of function f. The shorthand way of writing that as one, and we write it like this. So basically they are same. We'll look at a very simple question first. So say my gx is given as 2x plus 3 and fx is equals to x squared plus 1. And in this question we are going to find fx and gx both, f fog x and g of x both. So let's start with fog x, which is nothing but f of g of x. Now gx is already given here, 2x plus 3, so this is the output of my gx. And now when we're trying to find f of this, we just need to look at the definition of fx here, and what it says is that whatever you give to f, it will square it first and then add 1. Yeah, so repeat that. We look at fx, and fx says that whatever you give to f here, we are giving x to this f, and it squares this x and add 1, and that's what we get. So thus we do the same thing here. We square this thing. We are giving 2x plus 3 to the function f. So this function will square this thing and then add 1 to this. So this will be, and you can simplify that. That is 4x squared plus 4 and 3, 12x plus 9 and 1, 10. Now we need to find its domain and the range. So domain, we are looking at domain here. We look at this function, and this is a quadratic. Yeah, and as it's a quadratic, we know that it can have all values of x. Yeah, so it will become clear once we look at what its shape, how it could be sketched. So domain is so that x is a real number. Okay, when we come to range, we can look at this equation, and this equation gives us so much information. Yeah, let's look at this equation and let's analyze it. If we analyze it properly, it gives us so much information. So first thing we see is that it's a quadratic. So, and the coefficient of x squared, the 4 here, the coefficient of x squared is 4, which is a positive number. So it's a quadratic which would sketch like this. Yeah, if the coefficient of x squared was negative here, then it would sketch like this. Yeah, so obviously, because the graph would look like this, we will have some sort of a range, because whole real line will not be included in the range of this function. You will have y values only above this vertex. Okay, second thing that we can see is we look at its discriminant, and the discriminant tells us, we can find the discriminant here. Discriminant is b squared minus 4ac, which is 144 minus 4 times 40. So this is a negative number. It means this function does not have any real root, which means that it will not cross the x-axis. Okay, so now it tells us, it's giving you some hint about where it could be located. So it will be located above there, because it looks like this and it does not cross the x-axis, so it has to be somewhere here. or here or here. Yeah, very good. Let's then look at what kind of complex roots we could get from this. If we look at it, we see that the real part of the root comes from this here, because if you recall the quadratic formula, then it is x equals to minus b plus minus square root of b square minus 4ac divided by 2a. That will give you the imaginary part in this case, and this is the real part here. So we know that it will be real part will be negative, and most probably the vertex should be located somewhere to the left of the y-axis. We can find the vertex now. So easiest way to do is to make a square, convert that into a square. So this is my function, 4x square. I'll write that 2 times 2x times 3, and then this becomes 3 square, and 1 is left there, so that is 10. Yeah, so what I've done is I have split up, I've written this thing in such a this 12x in such a manner that I can see the whole, I can see whole square there by putting this 3 square here. So this is now 2x plus 3 whole square plus 1. We already know about this, we already had it here. So that basically gives us that the vertex of this graph would be minus 3 over 2 plus 1. We can look at how to sketch it using translation. I think it would be easier. All right, so we'll look at how to sketch this function using translation, although I will do another video later in which we'll see how a quadratic function can be sketched by translation. So this is what I have here. Now if I compare, I know that quadratic function that I have here is, this is y equal to x square. So when I look at this, what translation would make this graph, would convert this graph into this equation to this equation? So first thing is that I see that I'm replacing y with y minus 1, which means my graph would translate one step in the positive y direction. So it moves up by positive 1. It moves by 1 basically. That's what would I say. And the second thing is I see that I'm replacing x with 2x plus 3, which I could write as, I could say this is 2, oh sorry, let me correct that. It is 4x plus 3 over 2 whole square. So what I'm doing is I'm replacing x with x plus 3 over 2, which means that my graph should move left by 3 over 2. Yeah, so this vertex, which was initially 0, 0 in this function y equal to x square, this function vertex whose vertex was 0, 0, when I change this equation to this equation here, the vertex moves up by 1 and left by 3 over 2. So my vertex here is, I can show it like this, and this vertex here is minus 3 over 2 and 1. Yeah, looking at that, so that is basically the graph of our function here, and therefore the range of our function is, it is greater than, y is always greater than 1. So y such that y is greater than equal to 1, and y is a real function. Okay, let's so that was f of gx. Let's do a g of x as well. G of x, I'll keep it here. I'm not going to use it, but I could clean that up, but I have decided to keep it up. Keep this here. So g of x is g of fx and fx is x squared plus 1. And now we're going to look at gx here. Gx says that whatever you give to g, it doubles it first and then adds 3. So here we are giving x squared plus 1 to g. So what you need to do is you need to double it plus add 3 there. So that gives you 2x squared plus 2 plus 3, which is equals to 2 squared plus 5. Now again, the steps to find out its domain and range are similar to what we have done in FOGX. Again, this is a quadratic, so I will leave that for you guys and move on to next question, which I feel is a little bit tricky. So this is my fx, and gx is equals to x plus 2. So first let's find FOGX. So FOGX is equals to f gx, and that gives you x plus 2 here. And again, we need to look what f does to anything it is given to it. So when you give x to the f, you make it 4 minus x squared, take a square root and then add 2. So that's exactly what we're going to do. In effect, what we're going to do is, in place of x here, we will write x plus 2. So 2 plus square root of 4 minus x plus 2 squared. And that, if you solve it, simplify this, it will become, okay, let me show steps as well. Minus x squared minus 4x minus 4, and that gives me 2 plus square root of, let me write it like this, minus x squared plus 4x. Now we need to find its domain and range, and when we, sorry, let's move it a little back up there, back down there. Okay, so we need to find the domain and range of this thing. So to find the domain, we see that x can take only those values where this thing is positive, which means that we are looking at those values of, we are looking at x squared plus those values which makes x squared plus 4x negative or equal to 0. Yeah? So if when this thing is 0 or negative, the whole thing becomes positive and the function is defined. So we need to find what values of x makes its value less than equal to 0. I can write it x plus 4. This is what we are looking at. Now you could do that in many different ways. One way, easiest way, would be to just use a graphing calculator and see where the value of this quadratic is less than 0. But that wouldn't teach us anything. So what we'll do is we'll look at how to do it without a calculator. So we see that this function has got value of this expression becomes 0 when x equals to 0 and x equals to minus 4. At this point, this thing is equals to 0. So we can do a sign diagram here for this function, and that sign diagram will tell us what values would make this 0, this positive or negative. So this is my minus 4, and that's my 0, and this is a sign diagram of x squared plus 4x. Okay, so why do we use these values as the boundary conditions, as the values to divide your real line into? So because we see that this function becomes 0 at these values, so it means that this function would change its sign at these values, because it's coming to 0, so it might, most probably it will change its value as well. And so we see that these two values, minus 4 and 0, divide our whole real line into 3 regions. One region is here, another region is here, and third one region is here. And all we need to do is you need to check the value of this expression in with one of the values in these regions. So for this reason, I'm going to substitute a value of -2 here and see what sign, what's the value of this x squared plus 4x. So when I put -2 here, this becomes +4, this is -8. So the value of this expression in this region is negative. Okay, here in this region I can put a, oh, I made a mistake, not +2, I need to put a -6 here. So let's put -6 here, so that becomes 36, and that's -24, so this is a positive sign here. In this region I need to put a -2 here, so you put -2 in this expression, you get 4, and you put -2, that becomes -4, sorry, you put -2 here, that becomes 4, and that becomes -8, so this is negative. And if you put 1 or 2 here, this, you will find that this is positive. So the value of this thing is negative in this region, and that is our domain. Yeah, so the domain of fog x is equals to x, such that x is greater than equal to -2 and less than equal to 0, and x is a real number. Because when this is negative, that expression under the square root becomes positive, and we get our we get a value, we get some expression for our function. Now range, to find the range, what we need to do is, to find the range, we need to see what values we can get for y when x is between these, x is between -4 and 0. So what we'll do is we'll substitute 3 values and see what values of y we get. We'll substitute these values. Okay, when we put y equals to -4, my fog x will become, I'm looking at this expression here. So if I put -4, I see that this is -4, this becomes 0, so my f fog x equals to 2. Sorry, I can write it -4 fog -2. I put -2 here, so that becomes +4. This is -8 +4 -8 gives you -4, becomes +4. Take a square root 2, take a square root, becomes 2, so that becomes 4. And 0 again will be similar to -4, because we already saw that here, so that will become 0. Sorry, that will become 2. I'm not going in much detail how to calculate these things, but they're pretty straightforward. Just put the value of x in this expression here. Okay, so now that gives us the range. Your range is equals to y such that y is greater than equal to 2 and less than equal to 4, and y is a member of R. That's what you get for fog x. Next part is GOF x, and that I'll leave for you. Or maybe we can give it a go here, because I got one more problem that I will cover in next video. So okay, let's go back and see what fog x are. So sorry. Okay, so that is equals to g fx, which is equals to g of which again all you do is here in the gx, in place of x you write this thing. So what I get is 2 plus square root 4 minus x square, which gives you 4 plus square root of 4 minus x square. Yeah, and finding its dominant range would be a bit easier if you look at it. So it's to find the domain, we just need to look at the values of x, which makes this 4 minus x square positive. So what you want is that x square should be less than 4, less than equal to 4, and that gives us that x has to be within minus 2 and plus 2, and that gives you domain. X such that x is less than equal to minus 2 to x is a real number. And to find the range, all we need to do is we need to find what values of 4 what values you get for this square root for this part of the expression. So this part of the expression, all we can see that x has to be between 0 and 4. So the value of this, the expression inside the bracket, will be between 0 and 4. So what you get is a 2 here. Yeah, so there are two values that you can get here. I mean, let's do it. So g of x, when x equals to 0, I mean, you got three values that, if you look at this, are this here. So you can check these values and you will see that expression here can go from 0 to 2. Yeah, or if you want, I can explain that as well, so it won't take long. So I'll put these values of x, and then I find the value of g of x. So when it put minus 2 here, it becomes 0, so your value is 4. Yeah, when you put x equal to 0, you only left with 4, take a square root, it becomes 2, so this is equals to 6. And you put 2 here, again it becomes, this thing becomes 0, so you get a 4. And that gives you range x such that 4 less than equal to y less than equals to 6, and y is a real number. Y is a real number. And that's where we stop.